In Chapter 2, I want to introduce one of the core concepts of finance. And the way I'm going to do this is use a money machine. And let's say this money machine will pay $10,000 in exactly 1 year. You have no doubt about that. Nobody has any doubt about that. I'll show up at your class and say, I'm going to auction this machine off. I need money now, and I want to know how much people are willing to pay now. So we start a bidding war. Starts out somebody bids 1,000. They keep bidding up, and finally the highest bid is $9,130. Great. So that now is the value of the money machine. Let me ask you a question. What if I said, this is scenario 1, $10,000 in 1 year. You pay $9,130 for it. What about I said this doesn't actually pay in 1 year? I'm sorry, I made a mistake. This actually pays in 2 years. Will you pay more or less for that? Well, you'd pay less, right? I don't know exactly what you'd be willing to pay, but if someone was willing to pay $9,130 to get $10,000 in a year, they will pay something less than that to get $10,000 in 2 years. All right, let's look at scenario 3. Scenario 3 said, well, I know it's going to pay in a year. I was right about that, but I'm not sure. It's going to flip a coin. The machine here actually flips a coin. If the coin comes out heads, it pays you $20,000. And if the coin comes out tails, then it pays you $0. Would you pay more or less for this machine than the $9,130? The answer is less. So I have three concepts here. We're going to try to value cash flows. I want to value future cash flows. That's the whole point. Or you can think about it as valuing money machines. We're going to have three components. I want to know the size, the timing, and the risk of the cash flows. All right, so we can kind of understand intuitively that the size, timing, and risk of the cash flows matter. But I need something more than that. I don't just need someone to say more or less, and I don't need someone kind of guessing at this number. I need a precise mathematical definition for that. So let's work on that math portion for just a second. The way I want to work on that is I'm going to start with this timeline. It's going to look something like this, and we'll work through this, and we'll say, okay, today is time 0, and time 1, time 2, time 3. Let's say you put $100 in the bank and your interest rate is 10%. How much will you have in 1 year? Well, you may quickly look at that and say that's $110. But let's break down the math of why you said that. Well, I know I have my $100 I put in there, plus the interest rate of 10% means they will give me 10% of the money I have in there now, the 100. Add those together, that's 110. So if I move this up one more year, that's 121. Where did I get that? I said, well, now I have $110 in the bank at year 1, plus I get 10% of that 110. That's 121. How much is it in year 3? Well, that's 133.10. Where did that come from? Well, I have my $121 in the bank at year 2, plus I get 10% of that 121. That's equal to my 133.10. So let's see if we can get an equation out of this. What we did was we said this $100 becomes 110 in a year. So we had an equation 110 equals 100 times 1.1. Then 121 was equal to 100. Well, let's do it this way. It's equal to the 110 times 1.1, which is equal to 100 times 1.1 times 1.1, which of course is 100 times 1.10 squared. The 133 133.10, that was equal to the 121 times 1 plus the 10%, which is the same thing as 110 times 1.1 twice, which is the same thing as 100 times 1.10 cubed. Now let's formalize this. Let's call this 133, call that the future value because that occurs in the future. Let's call the 100 the present value because that occurs right now. And say 1 plus wherever the interest rate is raised to the number of years. Sometimes I'll use a t, sometimes I'll use a n, but raised to the number of steps. So if you want to take $100 and go 1, 2, 3 steps, then the value of that is the $100 times how big is the step? The step is 10%. How many steps did I take? I took 3 steps. So that's one way to look at it, but let me name this something a little bit different here. I can say, instead of future value, I can say that's the value at year t is equal to the value at year 0 times 1 plus r to the t. And if I don't want to use t's, I can use n's. Value at year n is equal to value at year 0 times 1 plus r to the n. Or if I want to get just a little bit more mathematical with it, I can do this. I can say the value at year n plus t is equal to the value at year n times 1 plus r to the t. But for our purposes, it's going to be good enough to think about this equation and think about this basic equation, and if you're a little more mathematically inclined, maybe think about that one. Okay, let me get rid of some of the writing here and we'll do our next step. Okay, think of the problem this way. What if you know you need to have $100 in the bank 1 year from now? How much should you put in the bank today? The interest rate is going to be 10%. And what I'll say is this, what we did before, so as we said, we already know future value equals present value times 1 plus r to the t. So that means present value is equal to future value divided by 1 plus r to the t. So what if I divide? If I come back this way and I say 100 divided by 1.10, that's equal to $90.91. Or you can think about it, well, is that right? Well, the $90.91 times 1.10 is equal to 100. So that's kind of the rule we're looking at here. Let me get rid of this real quickly. So I have 100 divided by 1.10 is equal to $90.91. What if I had $100 at time 2? Well, I need to have, let me say this, I need to have $100 2 years from now. How much should I put in the bank today? Well, you want to have $100 in the bank in 2 years. You're going to have it at 10%, raised to the second power. That's $82.64. Well, if I need to have $100 in the bank at time 3, that's 100 divided by 1.10 cubed, which is equal to 75.13. So we have this basic rule. Let me move this up and out of the way. We want to look at everything on a timeline. And we can label that timeline however we want. Year 0, year 1, year 2, year 3. And we know this rule, the future value is equal to the present value times 1 plus r to the t. So now I can ask one of two questions. Question number 1, if I put in $1,000 today, how much will I have, pick a year, at year 2? Well, you need to tell me the interest rate. We'll keep it at 10% to be simple. So in that case, the future value, which is equal to the value at year 2, is equal to the value at year 0 times 1 plus r to the 2. So the future value is equal to the 1,000 times 1.10 squared, which is equal to $1,210. Okay, let me get rid of this. The other way to think about this, instead of putting money in the account today and wanting to know how much you will have in the future, you can say, I need to have $1,000 in my account in 2 years. How much must I put in there today? Well, then you know the equation is present value equals future value over 1 plus r to the t. So present value, the value today, is equal to the value in 2 years divided by 1 plus r squared, which is equal to the $1,000 that you need divided by 1.10 squared, which is equal to $826.40, maybe a little rounding error. So one last thing here. Note that we have 4 different variables in this equation. So I'm going to get rid of all this, put our basic equation up again. The future value is equal to the present value times 1 plus r to the t. We've already know how to rearrange that and say present value is equal to future value divided by 1 plus r to the t. Well, if I want to solve for r, well, I can say future value divided by present value is equal to 1 plus r to the t. I think back to my algebra class in high school, and I know that if I raise both sides to the 1 over t, so take this and raise both sides to the 1 over t, that will be future value over present value raised to the 1 over t is equal to, and that's a t, 1 plus r. So r is equal to future value over present value raised to the 1 over t minus 1. Well, if I want to solve for t instead of solving for r, start at the same place. Future value equals present value times 1 plus r to the t. Future value divided by present value equals 1 plus r to the t. And now I have to think back to my high school algebra class and know to take natural log. So natural log future value over present value equals t times natural log 1 plus r. So t is equal to the natural log of future value over present value over the natural log of 1 plus r. So you can either think back to your algebra and remember how to do that. We'll also show you how to do all these on the calculator later on. I think it's a lot of value, particularly if you're a finance major, to know this math. If you're a marketing major, management, or something not a finance major, maybe it's not as important to know the math, but it's important to sort of see where it comes from. So what I really need you to do, the most important thing here, is know this equation. This is foundational to everything else we do in the entire book. So memorize this, memorize this, memorize this.